Hi everyone! So let's be clear, the special aspects of your data can provide a lot of insights into the situation of a disease or an outbreak. You can answer questions such as which districts have the higher incidence of cases, what is the spread of a disease, and where are the current disease hotspots. In this chapter, you are going to learn how to build accurate and informative maps. But today, you are going to learn why to use R to address all of these tasks. Let's start. Okay, so here are the learning objectives, and you can pause this video to read through them. We're going to start with what is a geospatial analysis. A geospatial analysis implies analyzing your data with geographic locations or coordinates. This means information that is related with certain positions on the Earth's surface. This analytic task is essential for epidemiology. For example, you can identify hotspots and potential high-risk areas for communicable diseases spread. As an example, we're going to see how to build a map of malaria prevalence predictions in the Gambia. In all of our examples of today, we're going to see code in three parts. First, how to get the packages. Here, we're going to use different packages that allow us to get boundary data and how to plot data related with special information. And finally, how to use interactive visualizations. As a second step, we're going to get data. In this case, we're going to get data from country boundaries and malaria prevalence data from local files. Finally, as a third step, we're going to plot this spatial data. Here we perform different tasks. We first add a background, then we add a prevalence surface above the background with an special color scale plus a coordinate system. And now we have our map. Here we can visualize how we plotted the prevalence values between 0 and 1 throughout the geographic surface, and we can see in which parts of this area we have a higher amount of prevalences predicted by a statistical model, and which areas have the lowest values of prevalence. With this map, we want to show how we can build informative maps with geospatial data. In this chapter, we're going to specifically learn which are the skills to make geospatial visualizations in order to create accurate, elegant, and informative maps. So now let's take a look on how we can use R as a GIS. In general, geospatial analysis needs geographic information systems. A GIS is a software or a platform that allows us to manage, analyze, and visualize spatial data. Among these platforms, the most popular ones are ArcGIS and QGIS. Both of them use graphic user interfaces. This means that these platforms work with point and click interfaces, which indeed they are really helpful for learners to start using it. So why use R for geospatial work? So we need to review some of our advantages. First, let's talk about reproducibility. So, with R, you have code that is straightforward for anyone to run, included your future self. You can easily build over others people's work, and it also facilitates collaborations. For example, you can paste this code and reproduce this map in your computer. Again, we have the 3 steps. First the packages, then the data, and finally the plot. So we can get the SF and ggplot packages to get access to spatial data available in the SF package, and then create a plot with it. In this way, if I can create this map on my computer, you are also able to reproduce it and modify it using my code as a template. This helps us to accelerate the scientific process. Now let's talk about reporting. So R have an amazing platform to build really interesting reporting styles. You can use R Markdown, Flex dashboards, and Shiny to generate reports and dashboards. For example, you can have interactive maps within a dashboard using packages like Leaflet instead of ggplot2. Let's take a look at this piece of code. Again, first we're going to get access to the packages, and we're going to replace the ggplot and put it Leaflet instead. We're going to use the same data before, and we're going to use a different piece of code to build the visualization. Okay, so let's check at this result. This is an interactive map because this allows us to zoom in or to zoom out to put our spatial information into the geographic context of the world. In this case, this is information from United States. Now let's talk about one more advantages, the rich ecosystem. R is a rapidly growing environment with a lot of libraries or packages being built by our active community. Everyone can build packages to reduce certain tasks, and they include ready-to-use functions or tutorials to use those functions into our work. For example, we can build the same interactive map as above with only one line of code. This is achieved by replacing map view instead of the leaflet packages. Let's check. Again, we're going to first import the packages and replace map view, and let's use the same data before to finally visualize the output of the map view function. Okay, so now we can see that we have a different format of interactive map, and it have an additional feature that we can visualize the number of cases that are depicted inside each area of this map. Again, we can also zoom in or zoom out in order to contextualize our information into their spatial and geographic context. So now let's talk about the convenience of using R. The best of this is that you already know how to use R, and this allows you to explore new pieces of code to build different new things for your data analysis tasks. As an example, we will use the tmap package and make minor modifications of it. Again, we're going to see that we can run the package line then load data for this map and make a quick plot. Okay, we have our plot, but now there is an interesting chance of apply all of these suggestions to make minor modifications of the code above. And let's see how we can understand this new package through making these modifications. For example, I'm going to start with the first one. Let's change the map title from my map to New Zealand. So now I only need to find where is my map, and it's inside the TM layout function within the main title argument. And I'm going to specify here New Zealand. Okay, so let's rerun this piece of code and check that our modification have changed this output. So now it's your turn. Take your time to play with all of these modifications and start customizing this plot according to your needs. Now, finally, our last advantage, the integrated workflow. With R, we can combine geospatial visualizations and statistical analysis. Specifically in epidemiology, where you maybe would need to make different type of analytical tasks before getting to the visualizations, and all within a single script. For example, we can build three-dimensional maps with the Reproducible package, following the tutorial available in this link. Here we can find a complete workflow of different pieces of code to build this plot. And we can also create bivariate maps to identify the unequal income distribution in a country, following tutorials like the one that is available in this link to create maps like this one, where we can identify two different variables in one map, the inequality and the income. So let's wrap up. Today we learned why to use R as a GIS environment and to take the coding advantages of R to perform these spatial visualizations. But which maps are we going to build during this chapter? We are going to build a specific type of map which is called thematic map, and it contains couplet maps, dot maps, and density maps. During the following lessons, we are going to learn how to build thematic maps step by step using the ggplot2 package from different data sources and illustrative annotations. So hopefully now you know why we are going to use R as a GIS environment to make all these maps. See you in the following lessons to keep creating maps. Bye.
For more resources, visit our website, where you can track your progress, access interactive quizzes and lesson notes, and connect with our teachers and other learners like you. And if you'd like a more guided experience, we also offer live online bootcamps with expert help. So join us at thegraphcourses.org to start your learning journey today.